Right. So today we are looking forward for we want to formulate differential equation. So you can write formulation of differential equation. Hello?
Hello.
Yes. So you can write formulation of differential equation. We are now on the formulation of differential equations. Yes?
Yes.
Yeah. So write formulation of differential equation. So before we formulate, we want to just look at few things, especially on proportion. I think you have done proportion from your O level, right? You know proportion, direct proportion, inverse proportion, you know it?
Yes.
Yes. So like if you're saying y direct is direct proportional to x, this one is direct proportion, right?
Yes.
And as an equation, how do you remove the proportional sign? It will be y is equals to what?
X.
Y is equals to kx, right?
Yes.
Then we also have the inverse proportion, and we say if x is inversely proportional to x, it will be like 1 over what? 1 over x. And if you remove your proportional sign, you are going to get y is equals to k over x, right?
Yes.
That is proportion. So we are also going to fit these words like saying directly proportional, inversely proportional. So we are going to come up with some of the variation when we are formulating our differential equation. Right. Next, we want to look at rates. I think we have done rates of change as the application of differentiation. You still remember
Yes.
rates of change where we said if ever I say rate of is over dt. You still remember?
Yes.
Okay. So can you write this statement? Can you say rate of change of x, rate of increase, the rate of increase of x is denoted by the rate of increase of x, the rate of increase of x is denoted by dx over dt. Yes?
Yes.
So that one is the first statement. Your next statement on number 2, can you say the rate of decrease of x, the rate of decrease of x, the rate of decrease of x is denoted by negative dx over dt. So if a variable is increasing with respect to time, it will be positive. This rate will be positive, right?
Yes.
And also if a variable is decreasing with respect to time, this derivative is going to be what? It will be going to be negative, right?
Yes.
So when we are going to formulate this differential equation, sometimes you are not going to see or to notify direct. That is, they are saying decrease, rate of decrease. No, we have keywords that represents decrease. Or maybe if we are looking at a population like the death rate, what will be happening to the population? The population will be decreasing, right?
Yes.
So if you are given the death rate and you are given a P as your population, we'll be rather saying the death rate is represented by negative dp over dt, right?
Yes.
So you have to come up with these ideas of saying, no, I'm giving a death rate. So if you are giving a death rate, the population will be decreasing. So your death rate in terms of P, you are going to write it as negative dp over dt. But if it is birth rate, it will be positive dp over what?
dt.
Over dt. Because the effect of birth is like we are population is increasing, but under death the population will be decreasing. So sometimes you'll be given birth rate and also the death rate. And if you want to find the effect of that, you'll be just adding your birth rate plus your death rate, right?
Yes.
So you need to take note of those crucial points. And also under the negative side, sometimes you'll be given a scenario whereby you have a hot body which is allowed to cool down. So the moment temperature decreases, it's now maybe our temperature is theta. So it will be now d theta over dt. Maybe they are saying a body is decreasing, it is cooling down. It will be what? Negative d theta over what? Over dt. So they will be saying temperature is cooling down. So it will be a negative what? Derivative, right? The rate of change it will be negative. Are we together?
Yes.
Right. And also, which aspect again do we have here? I think for right. And also, you need to take note of these terms. I think you know e to the power of zero is what?
1.
It's one, right? There's this idea of saying maybe because we are talking about rates. When we are talking about rates, we'll be talking about time, right? So sometimes, so if you can write this one down, I think it would be helpful. Can you say when time becomes very large, or when t becomes very large? When t becomes very large, t approaches to what? Approaches to an unknown value, which is going to be an infinity. You write in statements when t becomes very large, t is approaching this. If you write this one, this means t is approaching to infinity, right?
Yes.
So maybe if I'm saying start from now to count time in terms of hours, so up to tomorrow you'll be counting 20 hours, 24 hours, 27 hours, up to where? Up to infinity. So whenever you hear something saying as t becomes very large, they will be saying this t is approaching to infinity. So there's this result that you should know. If you take an exponential and raise it to a negative infinity, you should get zero. This result is very, very important. If you have a negative infinity, you must get your result as what?
0.
As zero. So suppose we have this expression. It's very, very important. Suppose we have got this expression where we are given your y is equals to 2 to the power of x over maybe uh, to the power of x plus 5. Right? Suppose we have this expression. Then they say, right? Can you write? Explain what happens to y if x becomes very large. Explain what happens to y if x becomes very large. Can you write it as a statement? Explain what happens to y when x becomes very large. when x becomes very large. Right, are you done?
Yes.
Right. So, like I said earlier, if x becomes very large, we are saying x is approaching to infinity, right?
Yes.
And we also have to use this result saying e to the power negative infinity. You should get what? You should get 0, right?
Yes.
But as you can see here, do we have a negative power for the exponential?
No.
We don't. So you have to simplify that expression until you have a negative power for the exponential. Like you can say divide each term by e to the power of x, like simplifying your right side. Let's divide each term by e to the power of x. So on the numerator, you are going to get 2, right?
Yes.
Then the denominator, you are going to get 1 firstly, right?
Yes.
And if you divide 5 by e to the power of x, you are now going to get a 5 e to the power of minus x. Are we together on this one?
Yes.
If you divide this one by e to the power of x, you get this, right?
Yes.
If you divide this one by e to the power of x, you get 1, right?
Yes.
Then if you divide 5 by e to the power of x, you get this, right?
Yes.
We now have a negative power for the exponential. So if we have the negative power for the exponential, we are now going to substitute infinity where there is x. So we are going to say 2 over 1 plus 5 e to the power of minus infinity, right?
Yes.
And what is e to the power of infinity? We are going to get what?
0.
So this cancels out. So if x approaches to infinity, means say if x becomes very, very large, our y is going to be equals to what? Or our y approaches what? Approaches 2. Y becomes 2 because we have 2 over 1, right?
Yes.
So these statements, they are very, very important when you are doing a formulation of differential equation. So I think for now we are now good to go to try and formulate any given statement under differential equation, because you'll be given number stories, a paragraph. Then from that paragraph, try to make any expression from any sentence that you are given. If you read a sentence, try to come up with an expression mathematical. Is it dy dt or is it dx dt? And if it is your rate, is it in decrease or is there an increase? So we want to look at this one first. The one is saying November 2010. This one, we want to look at this one. Let me try to zoom. What happened here? Is it visible?
Yes, it is.
Mm, my battery is very low. Eh, can you try to screenshot? Or maybe let me try to take a pic from here so that we go to our whiteboard interpreting the. Let me try to take a pic from here. Right. Did you manage?
Um, yes, but it's not very clear.
Let me
I
see.
took a picture of the screen.
Let me try to see if I can. Right. I've managed to take it here. Let me send you. Let me forward you the pic. Right. Right. I think I've managed to forward. Is it clear over your side?
Yes, it is.
Right. Fine. So maybe you are going to leave a space for that. Then let's try to answer our solution. Maybe try to leave a space for writing your question. Right. The question is saying what a certain substance. Let me go. A certain substance is formed in a chemical reaction. Then they went on saying the mass of a substance formed t seconds after the start of the reaction is x grams. So we are saying we are forming a substance, right?
Yes.
Then the mass of that substance after t seconds after the start of the reaction is represented by what? By x grams, right?
Yes.
Then they say at time t, at any time, the rate of formation of the substance is proportional to 20 minus x. You see the one that I'm underlined. You say the rate of formation, right? What is rate? Rate is over dt, right?
Yes.
The rate of formation of the substance, like this one, the rate of formation of the substance is proportional to this one. So we can come up with an expression mathematically. Yes, this one is a sentence, but let's write it mathematically. Rate of formation of the substance, isn't it dx dt?
It is.
Yes. So rate of formation of the substance is dx dt. So firstly, we are having our dx over dt. That is the rate of formation of the substance. Both they are saying the substance formed is x. So the rate of formation is dx over dt. Is proportional. This one is your proportional sign. Is proportional to what? To 20 minus what? Minus x, right?
Yes.
So it's proportional to 20 minus x. So we have come up with a mathematical expression from a sentence because we have managed to identify that we have this rate of formation. So it will be positive because we are forming a substance. And this one is proportional, it's direct, just say direct proportional, right? And we are giving the initial conditions. These now, they are now the initial conditions given, right?
Yes.
So we are given t is equals to 0. Let me see here. My we are given t is equals to 0. We are also given x is equals to 0. And also we are given dx over dt, right?
Yes.
Dx over dt is equals to what?
1.
Is equals to 1. Right. These are the initial conditions given. And now they are saying that show that x and t satisfy the differential equation dx over dt is equals to 0.005 open bracket 20 minus x. So now it's now a matter of simplifying this. Let's remove our alpha here, the proportional sign. It will be dx over dt, right?
Yes.
Dx over dt is equals to, if you remove the proportional sign, what do you have? K, a constant, right?
Yes.
K open bracket 20 minus x, right?
Yes.
Are we together?
Yes, you are.
So we are now going to substitute these conditions for us to find k, because here we don't have k here. Maybe k is this one. They've solved it for you, k. So they want you to show that k is supposed to be what? 0.05. As you can relate this equation and this equation, this one. So can you go and say where there is dx over dt, we are going to put what? We're going to put 1, right?
Yes.
And where there is x, you put what? 0.
0.
So you have 20k, right?
Yes.
And what would be your k?
1 over 20.
And what is 1 over 20 in decimals?
0.05.
Yes, 0.05. So we have managed to show that we have our dx over dt is equal to what? Is equals to 0.05 open bracket 20 minus x. We have managed to show that will be our differential equation. This now is now a differential equation. We have formulated a differential equation. It's now a differential equation. We have formulated that differential equation from given statements, right?
Yes.
Yes. So next part from that, they will be saying try to find the solution, like part 2. Find in any form. They're just saying in any form. Find in any form. Any form that one. The solution to this differential of this differential equation. So we are now starting from what we from where we ended yesterday, where we are given, you were given the differential equations already, then they say to solve it. So we are now going to follow those stages whereby we say separate your variables, then after separating your variables, integrate both sides, introduce a constant of integration to one side, and so forth. We are now starting from that point. But the main issue was to formulate a differential equation, right?
Yes.
Right. So let's try to solve. Let's separate the variables. What are you going to do here? Let's separate the variables. Dx over dt is equals to 0.05 open bracket 20 minus x. Let's separate the variables. What are we going to have, Mr. Michael?
Multiply all the terms by dt.
Sorry, I can't hear.
We multiply all the terms by dt.
Yes, firstly, multiply all the terms by dt. So we're going to have dx is equals to 0.05 open bracket 20 minus x dt. Have we managed to separate the variables?
No.
No. So next, what are you going to do?
Divide by 0.05 open bracket 20 minus x.
We divide by,
0.05 open bracket 20 minus x.
mm, next time when you are separating variables, please don't divide by a constant, divide by variables. Like we have this bracket 20 minus x, you divide it by that both sides, you are going to divide this one. Because if you divide again with the 0.05, I think your differential equation will be very, very complicated. So it will be over here 20 minus x. Just take those parts with the x, because that bracket, it's a one bracket, so it's where we want to separate our variable. So this will cancel this. So at the end, we are going to have 1 over what? 1 over
Minus
20
x.
minus x, right? Are we together on this one? When you are separating variables, if we have a constant multiplying a variable that you want to separate, don't separate that constant. Just take the variable. Like in this case, the variable is inside this bracket. So we are going to remove this bracket only and leave a 0.05 to the right side, right?
Yes.
So here we are having 0.05 dt, right? Are we together?
Yes.
Right. So now after that, we've managed to separate our variables. We are now moving on to integrate both sides. We are now integrating both sides. Let's integrate here. Integral of 1 over 20 minus x dx is equal to integral of I want you to see something like if I take 0.05 outside here, I'm going to remain with 1 dt, right? Let's integrate to your left hand side. What is your answer if you integrate that one? What do we have if we integrate the left hand side?
I think it's minus ln j minus x.
Yes, it's negative. Using recognition aspect, it's negative ln of 20 minus x, right? Then to your right, what do you have?
0.05 t.
It's 0 point,
05 t
yes, 0.5t and what?
plus c.
Yes, plus c, the constant of integration. Yes,
Yes.
right. Now we want to find the solution. So the solution, is it a particular solution or is it a general solution? What type of solution are we solving for?
Particular.
It's particular. Why? Because we are given the initial condition, right?
Yes.
Let's go and substitute. Where there is t, put 0. Where there is x, put 0. What do we have? If we have t0 here, we are going to remain with c only here. Where there is x, if we put 0 here, we are going to get minus ln what?
And
Minus ln 20. So our c is it's negative ln 20, right?
yes.
Like I said before, please don't take a calculator and say what is your negative ln 20. Then you write your answer in decimals. No, just leave it as it is. Let's go and substitute it back here. Where they see, go and put minus ln 20. So you'd see your equation is going to be negative ln 20 minus x, is equals to 0.05 t minus ln 20, right? Are we together on this one? Hello? Hello? Oh, I've lost my connection. We were on. Did you see how we have found the constant of integration C, like minus 20?
Yes.
Where there is x, you put 0. Where there is t, you put 0. Then I was explaining that if you find that constant is minus ln 20, don't take a calculator and substitute into a calculator. Then you write it as a decimal. Don't write it as a decimal. Just take minus ln 20 as it is and go and substitute with C, so that you are going to get this one, right?
Yes.
And the question is not they are just saying find in any form the solution of a differential equation. We want to find in any form that you want. So the moment you substitute the value of C, is now your particular solution. So one can say this is my format, so this is my answer. It will be okay with that. You get all the 5 marks. You get all the 5 marks. Because they are saying in any form. Yes?
Yes.
Yeah. So that is my format. So if you want to find, if you want to leave it like this, it's okay. You get your what? You get your 5 marks. But let us simplify. Let us simplify. Let's make x in terms of t in this case. What if I take minus 20 here to this side? I'm going to have what? It will be positive ln 20, right?
Yes.
So it will be positive ln 20 minus ln that. So using laws of logarithms, it will be ln of 20 over 20 minus x, right?
Yes.
Are we together?
Yes.
Right. Is equal to what?
0.05 t.
0.05 t. So now, if you want to make our x the subject, now you can introduce a exponential. Let's introduce the exponential. These cancels. What do we have here?
20 over 20 minus x.
20 over 20 minus x is okay, fine. Zero 0.05 t. So that over 20 minus x is going to multiply with what? With 20 minus x, right?
Yes.
And I'm saying I want to make my x subject. I want to make my x subject. So I'm saying let me remove everything that is multiplying with x. So what if I divide each term by this exponential? So I'm going to have 20 over what? 20 over e to the power of 0.05 t is equals to, I will have 20 minus x here, right?
Yes.
Then let me write this one in a simplest form. Isn't it this as 20 exponential of negative 0.05 t, isn't it?
It is.
Yes. Like so is this one. So if I'm to make my x the subject, my x will be x is equals to 20 minus that. My x will be 20 minus from here, from this stage. If I'm to make my x the subject, if I take this x to this side, it will be positive x. Then if I take this to this side, it will be negative, right?
Yes.
Let me try to remove this. So if I'm to simplify it further, let me put it up here. As you can see, you can factor out 20, right? Because 20 is common.
Yes.
We can factor out what?
20.
We can factor out 20. So finally, our x will be what? Our x is going to be 20, open bracket, 1 minus e to the power of negative 0.05 t. Right?
Yes.
So that is our simplest. But according to the question, your answer, you can get your all the 5 marks from here. So, because they were saying in N4. But if they were going to say make your x the subject, that would be our ideal x. 20, open bracket, 1 minus e to the power of negative x. So that is this part where you have your 8 marks. Then for part 3, what are they saying for part 3? Find the value of x when t is equals to 10, giving your answer to 1 decimal. We want to find the value of x. Let's go back here. What is the value of x when t is equals to what? When t is equals to 10. Can you go and substitute where this? I don't have a calculator here. What is x when t is equals to 10? To 1 decimal place.
7.9.
It's 7
9.
Okay, that will be your answer. 7.9. Right? We have done that. Next, state what happens to x as t becomes very large. The one that I was saying. You see, this one. State what happens to x as t becomes very large. And I said, when t becomes very large, it's t being referred to as what? Raised to infinity, right?
Yes.
T becoming infinity. Yes. So we want to find the value of x. What happens to x as t? Let me try to write it. Let me try to erase this one. Okay. Right. As t becomes very large, we said t approaches to infinity. So if t approaches to infinity, we want to find the value of what? Of x. So let's go and substitute into our original equation. What do we have? So we'll be saying x is equals to 20, open bracket, 1 minus e to the power of negative. So the moment I substitute infinity, everything becomes infinity. because infinity is a very, very big number. So a very, very big number, if multiplied by another number, it's infinity, right?
Yes.
So we said e to the power of infinity becomes what? 0, right?
Yes.
Then you remain with 1, and 1 times 20, you get what?
20.
So if a t becomes very large, your x is going to what? To be equals to what?
20.
Your x is going to be equal to 20, right?
Yes.
So that was the question on finding the on formulating the differential equation, right? Because of
Yes.
my, let me see here. Let me see the percentage here. 15%. Hey, can you try to formulate this one? Let's try to do this one. Let me try to take a picture. Can you try to do this one?
Right.
Let me. My battery is very low to take. Let me try to. Can you try to do that one? Let me try to forward it to you.